So, hi everyone, good morning. Thank you everyone for being here on a Saturday morning. We have with us Romil, who is the co founder of Outdefine.com, a vetted talent marketplace for engineers built on the blockchain. Previously, he co founded a venture backed startup that raised $10 million in funding. He has also been an engineer at Google and studied computer science at Stanford. Today, he would be talking to you about journey to the cloud computing. With this, I would hand over the virtual mic to Romil, and thank you, for coming, Romil, and we look forward to your interaction now.
Yeah, thanks for that, Anamika. I appreciate having me on this live stream. Uh, like you mentioned, I am Romel. I'm the co-founder of Outdefine. Outdefine is a better talent marketplace where engineers globally can, get jobs, high-paying jobs, and also earn, tokens on the blockchain for the work that they do. So trying to create something in the Web3 space, if anyone has heard of that term. It's pretty new and upcoming, and it's pretty exciting.
Right. Right. So I'm leaving the stage for you now.
Got it. Uh, okay. So I'm happy to talk about my experience in cloud computing and my journey through that. Okay. So I can start with a little bit more on my background and help you guys share with my journey and tell you how I got here. So, uh, I was very, very passionate early on to study computer science. Back in India, in high school also, there was like one subject that I was very good at, and that was like computer science. So I knew I wanted to be an engineer, and that's how I got into. And I also knew that I wanted to study in the U.S. Um, so going for studying for undergrad in the US is not something a lot of people do, especially when they're in India. But I really focused my admissions process in trying to find colleges that give like scholarships. So I applied to all the colleges out there that were good with computer science studies, and they offered scholarships. And I went to Purdue. I got a full ride scholarship over there, and I spent about like 3.5, 4 years over there, doing a lot of like research, and that's probably the first time when I got introduced to like the concept of cloud computing, and this was back in like 2012, 2013. So very, very interestingly, like Purdue University had uh, access to supercomputers, so where you could run like different algorithmically hard problems. You could, you know, solve like, multiple like, data sequencing problems by accessing massive amounts of computers. And what was very interesting to me is like just through a command line, through a Linux shell, you could access like, tens of thousands of these servers and be able to like, spin up and make them do some job in a very parallel processing way to help compute whatever, problem that you're trying to solve. And that was very different than the world that we had back in like, the 1980s or the 1990s, where uh, you know, if you wanted to do any kind of computing, you would have had to, spin up your own, you know, take these racks, put them in your house or put them in your office and be able to like, host data over there. But with the advent of like, cloud computing, suddenly everything is abstracted. You can sit on your laptop and you can be anywhere in the world and you can have access to like, tens of thousands of machines, whether you're trying to do like, AI or machine learning or data training, or you're trying to do uh, you know video recording, or even like, using Word. You don't need to have that software be downloaded on your network. And this shift in paradigm has helped companies, people, developers, has helped engineers, build products much, much faster. You'd famously see how, companies accelerators like Y Combinator, uh, they give like, $125,000 in funding to companies to start off their idea. And that is because now, the cost of capital has really, really reduced. Like, two, three engineers sitting together can really, really quickly build a product and like deploy it. And they don't have to worry about where do you host it, how do you serve it? Is your application running? Uh, you know, Electricity is not going to stop your computer and so on and so forth. So, so that was my first foray into cloud computing back in 2012, 2013. And I was like very, very excited about that. And then I went to Stanford, which is an incredible university, and I studied computer science over there. Um, and there, I started to leverage the cloud to do a lot more work on the artificial intelligence side, on the machine learning side. So this was back in 2014. Stanford was at the forefront of what AI and ML was doing. And now the industry has really, really caught up to it. And uh, you know, it was very interesting because as a student over there, I was, even as part of my research assignment, we had like, uh, you know, tens of gigabytes of data, and we were allowed to, we were given the homework used to be to write these machine learning, train these machine learning models on the data so that you can do some sort of like, prediction. You can do some sort of like ranking example, like predict whether this image is an image of a cat, or predict whether this, uh, you know, this is an image of a car, and so on and so forth. And then you could take like, tens of gigabytes of data, which is not available to you, which is sitting somewhere, remotely. You access it, you create a model on it, and then you deploy it. So uh, when I went to Stanford, I was able to see in a more deep dive way what I was able to deep dive and see what the industry was like, in the sense like, how was exactly cloud computing being done, right? You have heard of massive, massive companies like Google and Facebook that have, data centers across the world where they're trying to do, where they transfer petabytes of data on a daily basis, right? And they not only like, are networking centers where they're like, transferring information from one part of the internet to the other, but they're also like holding on to, you know, uh, a lot of information. And and that got me really, really curious to understand how these like, massively distributed network centers and how the cloud actually works, right? And what is underneath it, right? How is Microsoft Azure working? How is the Google uh, the data center and the Google Compute platform working? So uh, I basically, when I started studying about how search was built and how you know there's like thousands of machines that are running at any time that is like crawling all over the web, all over the internet, and they're like indexing all of this data, and then there are machines that are creating these machine learning models on top of them to basically rank the results that are out there so that a user can get very personalized data. A user can get, if you search for like what is the news today, then you'll get like the most recent data. And what was very interesting about this, studying from a going in depth and actually seeing how all of this worked, was the aspect of, how databases, how machines were fault tolerant and how systems were created to be, uh, you know, designed for failure in some sense. Like, how do you like manage failure? Because at Google scale, you had, if you had if you had like 10,000, 20,000 machines that were running as servers in your data center, uh, at any point of time, just as a matter of statistics, you would have like on a daily basis have like hundreds of computers crashing, hundreds of their servers crashing, and it's very very interesting. Like if you ever see videos of data centers, there will be these like technicians who are spending a lot of their times just changing racks of servers, right? But it's very very incredible because Google or Amazon or Microsoft as a company is able to provide this infrastructure, which then translates to an end user like me or an end user like you who can basically say, I need access to a machine today, and I need access to a machine for like 400, for like, let's say 4 hours, or I need a machine for like that is running, continuously for the next 10 days because I'm trying to process some data. And these, and suddenly that compute power is available to you. And that is like really, really incredible because now you're able to, um, you know, do whatever you want to solve, and you can not have to, and you don't have to worry about, uh, like whether I have the computing resources to do it or not. So looking into how these machines and how these systems were built, I got very, very interested, and I ended up joining Google as a software engineer. And there I spent about 5 years as a software engineer at Google and in the Bay Area in Silicon Valley. And the first few years was really, really just to understand the infrastructure aspect of it. And this is very, very interesting because Google works at a scale of whatever change you're trying to do is impacting millions of users. So uh, there's a lot of alignment inside the company to be doing things that are good for the user and trying to make even something as simple as serving a website page or serving google.com page 10 seconds faster, or serving the search results page where when you type something like what is the cricket score today, you can you get it like 10 milliseconds faster than what you got previously. And there's like massive amounts of optimization that goes in to make something like that possible. For example, all the way from the UI, like how do you load JavaScript faster into bundles onto your onto your mobile phone or your browser when you're like searching for something, to the ranking infrastructure, like how can you make sure that whatever query is being searched, the results are cached so that they can be served to the user much quicker, to the end-to-end process where as a user is typing something, um, as a user is typing something, you can start predicting or start suggesting results. For example, there is Ben Gomes. He came from India, and then he did his PhD. He was the head of search for quite some time, and he's a senior vice president in Google, right? Uh, and I believe he built the suggestion feature where, as you're typing, how do I, then, whatever the popular results are that they start to show. I have a question over here on if learning Linux Advanced gives a plus. Um, so I'm happy to answer that question. I believe, you know, uh, there's a lot of different systems. Linux is an incredible platform that any engineer should be very familiar with. As an engineer, I spend a lot of my time on the command line because that is the way I access simple tools like Git, or if I'm trying to check out some code out there on a repository in GitHub, or if I'm trying to deploy something to Azure or to Amazon Web Services, right? So having an understanding of Linux is really, or even the base commands that you have in Linux is super super helpful. So would definitely recommend doing that. So going back to the story at Google, um, it was, what I try to point out is that as an individual, as an individual, you know, you have access to, um, you know, all the computing resources that are out there, and that allows you, or as a developer, to be very creative in what you're trying to do. You're no longer limited by saying that, oh, I can only develop something that is used by 10 people because I don't have the resources. You can write your program, you can write your application, and that can be used by thousands to millions of users. And the benefit of something like the cloud is today that it scales so well, and it scales uh very, very seamlessly, to an extent. There's always cloud works to an extent, and after that, you need to do a lot more things to actually take it to the next stage. But we can get into all of that later. For the initial B, for people who are just starting out, it's a very, very powerful tool that you have access to. Now, to talk about the example of how sometimes when even cloud hits its you know tipping point. For example, if people remember the game Pokemon Go, which I think it came out in 2016 or 2017 by a company called Niantic Labs, I believe. So Pokemon Go was about, you can download an app, and then you can walk around the street, and then you can try to catch Pokemons that are showing up. So it was a very, very interesting application, and when it launched, it gained such massive popularity that uh, you know for Google, its GCP, or the Google Compute Platform, almost hit an outage, right? Because they were everyone just jumped onto the application, and to serve all of those, there were not enough servers in the data centers, almost not enough servers, that it almost caused an outage in the whole compute platform. So there are always cases like that where there are real limits that when they're very, very popular, applications can cause these systems. But a cloud computing provider like Amazon or Google or AWS, they try to stay ahead of the curve by making sure the systems are always optimized, making sure very, very efficient in the amount of allocation of memory or resources that are being given for any project that is out there. So one of the key things as a developer that I learned at Google is developing things for scale, and what that really means is keeping these problems in mind, uh, if some of you have studied like computer science in high school or in college, you would know the concept of like algorithms. And algorithms is all about you know, figuring out the most efficient solution to solve a problem, right? You have some runtime complexity from a time and a space perspective, like, oh, does this algorithm run in like, linear time, or does this algorithm achieve like, linear space, or does it, you can do it like much faster. So I remember a lot of my technical interviews that I went through, especially, you know, with Google, with Facebook, different companies. I interned at Facebook before I joined Google. It was all about like, solving, these coding problems in a very efficient way. And some people talk about it, and some people say that, oh, this does not apply in the real world, that you don't need to be solving like how do you sort an array in the fastest way, or how do you solve this problem using a very funky data structure, and try to be very creative about it. But when you're actually building your applications that are being used by like billions of users, for the first 2 3 years of at my career in Google, when I was focused on infrastructure, we were trying to optimize for all of these problems, and we were trying to, um, you know, shave off like milliseconds and time to load something. Because when you say shave like 10 milliseconds of time from, uh, you know, millions of queries happening on a daily basis, that computes to like real material value. Like you're saving like years worth of time for people, and you know hundreds of thousands of dollars worth of like machine resources uh, for the cloud infrastructure. So there's always a very interesting aspect to keep in mind, that the reason why we study things like algorithms is, especially when you're trying to build applications and you're trying to build them for scale, you need to be able to you know, be aware and try to understand what consequences or what impact your algorithm or what your software will have on the resources. So there's like two worlds really, right? There is, and it's a good idea to have an example or appreciation for both sides. So there are some other questions that are coming up in the chat. W-
Yes, so one of them is a follow up question to the next thing. And he says that, how do I get started?
Yeah, I think the way to get started is very, very simply try to uh, it depends on what your interest is. If you want to build a web application, or you want to just build a simple website, you can consider something like putting something together, not on something like Square or Wix, where you can like drag and drop in a no code way, and your site will be live, but rather build some application, or you want to host your own website, and uh, go to a platform like Azure or AWS, or even Google or Firebase, and deploy it and see how it happens, right? Uh, ver- you know, the things to do is like create a Git repository, whether on GitHub or Bitbucket or GitLab, and then uh, download some library. For example, you can download like a a React framework project, a React project or an Angular project, and then you implement your code, whatever you want to show, design it, and then deploy it on the cloud. Deploy it on AWS. You can deploy it as a there are many tools in it, like there's like Amplify, or there is EC2. However you want to structure it, use create an account on AWS, create an account on Azure, uh, deploy your Git project on it, and it will build and make it live. So that's one way of doing it.
So there's another question. Should the development team invest time into breaking the service into microservices?
Yeah, so that's a good question. I have built applications. So for context, there are two programming paradigms. One is, you build a monolith application, and the other is you build a microservices application through a service-oriented architecture model. So a monolith application is somewhere where, you know, there is like one big bulky binary. And for example, you used to have these executable files that you have or executable programs that you have, and it's like one program, one application where everything is happening. So, uh, you know, you can, for example, if you're trying to build a banking system, then you can have like money movement, you can have like, transfer settlement, you can have, fraud detection, you can have all the different applications or modules that you need in your application be as part of one binary, and they all share the same, like, context and resources, variables, and information like that. And it's easier to send information across. A microservices architecture or a service-oriented architecture model is where, which is something that Amazon is very famous for, and that led to AWS being such a successful platform, is that every team within Amazon tries to operate in a black box, which is like they are responsible for their piece of the software or the business logic or their service, and then they talk to other services in a through APIs or through API calls, and they don't know how other services work, and other services don't know how they work, but they have like these contracts set in their APIs where they have these conversations. So when you are trying to decide whether you want to build a monolith application or a microservices application, you really need to think about what is the use case you're trying to solve, and how much scale are you trying to achieve with it. So for example, if you're trying to build a API company where you are doing some kind of like, payments API like Stripe, right? And your job is that, this API is going to be hit millions of times or hundreds of millions of times. And it needs to be doing this one job very, very hermetically, and it can be like duplicated across many systems and deployed. Microservices make sense more, because then you can try to optimize each piece of the system in a very you know singular way. But if you're trying to build like a web application that is going to serve like tens of thousands of users, not so much that one application can handle it, then you don't need to go into the microservices world. So it really depends on the scale and the use case that you're trying to have.
I said, I have a question. So,
Yeah.
how important, according to you, is cloud for the DevOps engineer?
Uh, so there in inside cloud there are uh, two aspects. One is for any system that you're trying to build on it, you can have an automat a managed service, or you can have a more do-it-yourself kind of kit where you configure it. So a good example of that is something like having an EC2 instance where you decide how much resources you want, how much memory you want, how much uh, hard drive space, how much processing power you need, and then you as a DevOps engineer uh, figure out when do I scale it, when do I add more EC2 instances, when I do I host it in this time zone, when do I host it in different places, just so that I'm able to meet the requirements of the system or of the business application that you're trying to, you're working for. The other aspect is you let the application, you let the cloud provider themselves handle the scaling aspect, the DevOps aspect, right? So you can go with something like a serverless model where you as a developer are not very uh, concerned about how it scales, and you abstract it away and you let the infrastructure deal with it. So as a DevOps engineer, you should be very familiar with these trade-offs. These trade-offs occur in everything, including not just like, where you're deploying your application, but also how you're doing like your messaging. Are you using something like messaging queue? Are you using Kafka? One is managed, one is like you configure yourself, because then that has real world implications for your engineering team. Uh, and it's a question that you want to decide, like, how much flexibility and control you want, versus how much like fault tolerant you want your system to be, and how much you want to focus on like programming versus DevOps.
Perfect. Thanks. So the other question is, what do you prefer, working on a single cloud platform for a project or using multiple cloud platforms?
Yeah, so there are some tools out there. I think Google created the Kubernetes tool that allows you to deploy it on, it does not matter what platform or project you're running on. You can like transport your business logic over to different cloud providers. I personally prefer to work in the same environment. So if I'm building a project on Google Firebase, or whether in Microsoft Azure, or whether in AWS, then all of these systems are very, very well built out, to the extent where um, I can do most of my work over there. Now, of course, for some of the infrastructure that these providers provide, maybe it's like deployment, or maybe it's like monitoring, or whether it's like API logging. Uh, it makes sense to have access to some third-party tools that do sometimes a better job than what the native application, the native tool the cloud provider has. So I work in a model where you have, I work in one cloud platform, whether it's like Azure or AWS or GCP, and then I integrate different tools into it depending on what I need, whether I need like, if I want to host on Heroku, or if I want to do, monitoring with, Datadog, or I want to do like, reporting and alerting with PagerDuty instead of using the traditional messaging systems or logging systems that the provider provides.
I have another question here in the chat itself. So Lakshit says he is quite curious about your entrepreneurial profile, and his question is like, how do you manage your time and merge your ideas into the whole?
Sure. So I can give you a little bit of context on my entrepreneur profile. So I've um, so after Google, I have created about two companies. Well, one was in the fintech space, actually three companies, but one was in the fintech space where we were helping, retail users have access to investing in assets that are financial assets that are outside of stocks and bonds. So, they're called alternative assets. And these kind of assets are usually reserved for very, very high, ultra high net worth individuals. So we are trying to democratize access to that by, you know, making the cost of entry for anyone to be really, really cheap. So that was a very mission driven idea that I cared about. And I, built out the entire platform, and raised close to like $10 million in funding. And the platform deployed $80 million in assets for our customers. Uh, so, and then I did that project because I was very passionate about it. And then what happened is something very interesting has come into the market, like, similar to like 5 years ago when AI and ML was the key driving factor for innovation in the world. Now a lot of the innovation is being driven by crypto, and it is driven by the blockchain. And I'm very, very, as a undergrad student at Purdue, I did most of my research in, crypto and security, and, theoretical computer science. And I used those research to go to Stanford. where I again continue to do study, crypto and, networks and blockchain. So I've been very, very familiar with this space for quite some time. And now that a lot of like very interesting applications are coming up in the market for what you can do with tokens, what you can do with, with crypto. So I saw this opportunity that there is the time to build something in the, remote workspace where, engineers across the world can have access to global jobs. Of course, we saw that happen with COVID, where, now people want to work from home, but doing that has actually surfaced a lot of different problems. Like, how do you manage payroll and benefits, and how do you manage engineers getting access to the best of, jobs out there? And how do you manage, like, long-term incentives for what people are doing? And, with the shift in Web3, it has opened up new opportunities. And so that's how, I'm building Outdefine now, which is like a, talent marketplace that is built on the blockchain. So to answer your question, uh, a lot of things happen through the, first principles understanding, like, what do you think about the market and where the market is going, or if there's any technological improvements that are out there that are like, fundamentally rethinking the way, uh, the world is working. So that is one way I, you know, go after like, what needs to be built. And the second is like really on a very first principles basis, what are the problems that I see that I have faced being a remote engineer, hiring remote engineers for the last 4 years, and, what I can do in the world to, solve that problem.
Uh, so, from where should I learn about cloud from the beginning? So, how do I start my journey into cloud?
Sure. So, so that's a interesting question, in the sense that there are so many different ways of doing it. You can, um, a good way, it depends on how familiar you are with programming and how comfortable you are with being thrown into the deep end of the pool. So there's no right or wrong answer. You can either be like, oh, I want to join, I want to like start forking, or I want to start like, looking at code bases that are out there on GitHub, because GitHub is a profile where you have all of these online, you have these open sourced projects that you can be part of. So you can download one of them, you can play around with it, you can like modify it, and then you can like try to uh, you know then you sign up for AWS or Azure, and then you try to deploy your application on it, whatever was downloaded over here, and see how that works. And you try to tweak and change, and you create the whole cycle. You download this code, you test it, you deploy it in cloud, and then you continue to repeat that cycle. So that's being thrown deep end of the pool. If you're very comfortable with it, if you're already very familiar with any of the one cloud providers, or you're familiar with the open source ecosystem. The other way is like where you want a more structured way of like learning about what the cloud is, and learning about how do you build very, very simple applications. So there are a lot of different websites that are out there. um, there are different bootcamp programs. There are, YouTube is a great place where you can be like, oh, this is a project that I'm interested in, or, I'm interested in AWS. And there are like great YouTubers who can tell you about what, AWS is and what are the different tools in it, or how can you build a project in it. Like one of my friends, he's a YouTuber. He talks a lot about Android and Kotlin. So it's a little bit different from cloud, but he'll give you like examples of how to build Instagram, or how to build a Facebook app, because he has been he's a Facebook engineer, and before that he studied at Stanford with me. So uh, you know good ways of learning. It depends on whether you like to learn through videos, you like to learn by doing examples through a lot of different blogs out there, whether you like courses through boot camps, or like through school, or at tech companies. And the other way is like you like just like to be thrown in the deep end of the pool and be like, oh, this is something I want to try and figure out, and I'll go with it. Something that is really, really important is to have a good community around you. So definitely talk to people about, the questions that you have. Don't be shy about the problems that you're trying to solve. Talk to people. Generally people will help you find solutions much faster if you're like, stuck at something.
Another question we have is, what are your ideas on the cloud vendors like GCP, AWS, and Azure? If we should also learn to how to work in private cloud also.
So if I understand the question correctly, uh, the intention of the question is like, what do I think about the public cloud vendors like GCP, AWS, and Azure? If that's the case, they like I mentioned, they have really transformed the way companies or people or developers can like put their projects out onto the internet. And without them providing the infrastructure service or the platform service that they do, it would actually have been really, really hard to, or the cost of, taking something from like 10 users to 10,000 users to a million users would have been very, very high. Um, when you talk about private cloud, I think you're trying to say uh, set up your own systems and host your own servers. I guess that's what you're trying to talk about. I believe that was the 1.0 world, but most of the world has transformed or transitioned into the cloud space. Of course, there are legacy systems that are continuing to uh, stay in, the private case just because of business reasons or for security reasons or what have you. But I think the cloud is starting your learning on AWS, GCP, and Azure is like a good place to be.
Let me check if there are more questions there. Um, so there was one question: what are the drawbacks if we deploy the monolith as an into cloud?
So the drawbacks of deploying a monolith uh, into cloud. Um, like I said, it really depends on the use case that you're trying to solve. There's no right or wrong answer. It's okay to develop monoliths, even if you're trying to work with, tens of thousands of users or, you have like close to a million users. So if you can like estimate that, hey, this project that I'm building is going to be impactful to a million users, then you can always make that decision of, um, you know, it's a trade-off that you're trying to do. Like, should you, take the overhead cost of actually deploying things as a microservices for the work that you're trying to do? If you're working with like your tens of thousands of users, it may not be needed. But if you're working at Google and you're trying to like really really optimize for things, or you're working on at AWS in one of the teams, and you're trying to optimize logging infrastructure that's used by like billions of transactions on a daily basis, then it makes sense to invest in like really owning that piece and specializing on it. So building a monolith and deploying it into a cloud is not not a bad thing to do. It just depends on your use case uh, and how comfortable are you being able to manage it. And you just need to make those decisions whether you want to do DevOps on it or not. Do you want to manage it or not? Do you want to scale it or not? But AWS or any other cloud system gives you a lot of flexibility to deploy whatever you want. You can deploy and use it accordingly.
So this I'll come to the last question for the session. How do you see the 4C of cloud computing post pandemic?
Um, by foresee, so I think your question is like, how do I see uh, cloud changing post-pandemic?
Yes.
Yeah. Okay. So I don't. So the pandemic has made fundamental shifts in uh, a lot of different businesses or a lot of different, uh, you know, lifestyle changes. But the cloud transition really already happened in the 2010s to 2015, and from them the world has not looked back, and cloud has continued to accelerate and continue to grow. The pandemic has changed things like remote work. The future of work has changed, and the pandemic has changed or accelerated, you know, decentralization of work, decentralization of money through crypto, and those have really had much larger, changes or acceleration in the adoption curve than something like cloud, which is already, if it's a new company or it's an early stage company, they are all already building on the cloud, and most of the infrastructure is now aggregated by these cloud providers, and people are building on top of that.
Perfect. Thank you very much, Romel. And I think it should be your evening time, right?
Yeah, it's almost midnight for me, but
I know. So thank you. Thank you very much for your time. And we look forward to more interactions with you in future. And we'll bother you more. Thank you.
thank you so much, Anamika. It was great talking with you today.
Thanks.
Thank
Thank
you.
you very much. Good
Bye.
night.